Hello, this is Duncan Foley, and we're going to look at developing a Scara robot cell within the Stäubli software. So this is a tutorial booklet. I'll just go very quickly through it, introducing you to what we're going to do. So we're using, we're going to simulate a TS40 robot. Which is this one here. There's a range of them that Stäubli sell. They are specifically designed to have a work environment sort of like a cylinder. The last arm is basically going up and down, and you've got a rotation around its base. It's very, very useful for when you're picking and placing and inserting vertically straight down. If anything more complex, you're coming in at different angles and stuff, you need to consider using maybe the TX40 that we have at the university. So what you're going to do is get introduced to the software. You're going to create an application within the Stäubli software. And within that, you're then going to call up a robot. So we're going to go through the settings. We're going to change the emulator. The emulator is akin to the robot teach pendant, and it allows us to look at the teach pendant and see what would happen on the teach pendant without actually going to the robot. Check everything out before we actually send it to the robot. The Stäubli software comes with a complete library of robots, so we will select our particular one we're going to use, set some of the input-output ports, switch on the 3D view, and then start looking at the structure of how things appear within the Stäubli software. You can see our TS40s there, and we're going to have a quick move, rotate using the Cartesian and the joints views. Just move it around a little bit, just get used to moving it around. And then we're going to produce two boxes that are going to represent. One's going to be like the bench table, the bench that the robot sits on, and another one is going to be sort of a booster bench that we're going to put our parts on later on. So we get to change the size and stuff. The Stäubli software is not a 3D modeling package. We can do some really, really basic stuff, but that's about it, and it even struggles with that. So if you need some really complex 3D modeling done, use something else. I would recommend that if you are going to do any 3D modeling and bring it into the Stäubli, think about how much detail you need in that model, because it will slow the Stäubli software down terribly. So we're going to move the boxes around a little bit, put them in position, give them names, and then down the left-hand side of the software, there's something called the tree. We're going to have a look at that, and the robot. So we've got a robot here, and it's got all the joints, and right at the end, imagine the wrist of the robot has got something called a handler, and that's where we connect the gripper to. So we need to create a gripper. Ours is going to be a little blue disc, which is going to represent like a magnet. So we're going to attach that to the gripper. And then we're going to write a little bit of code. This code is not really complicated. I suppose it's complicated a little bit because you've never might not have seen this before, but what it's basically doing is it's a for loop. A little bit of the programs on the other page, but just scroll back up. So it does this loop 10 times. It moves using a J move. There's J moves and L moves. J move is more like it can have more curves in it and stuff. So it's like a Bezier movement, and it's moving to a point, and we're going to call it J start. It's going to have a gripper at the end called T tool, and it's going to move at a certain speed, and we're going to take the default settings for a variable called M faster, It's like M fast and M slow. You can create your own speeds and feeds, but for us it doesn't really matter at all. And then it's going to move to a point called pick 1, which will teach it. But we don't want it to move straight to the first position where the box is, to pick up a little box. We want it to approach it maybe just a little bit above, like vertically above, hovering above it, and then vertically go down towards the part and picks it up. So we have an approach point, so that's where a pro comes, and the value of that is set in this variable here called, we've called it TRSF approach 1, and we're going to say that that represents minus 15Z, so it's going to sort of appear wherever ppit 1 is, just above it, and then it's going to move to ppit 1, then it's going to move back up to the approach, then it's going to move to the approach ppit 2. We've got these wait M moves there. We put them in quite a lot. We want the robot can read these lines very quickly, and it might read that line and then read the next line before it's actually got to ppic 2. So it might miss it out because it's reading so fast. So this basically says wait M move. Don't do anything until the move that you've just been asked to do is completed. So we're going to move to where are we? Ppit 1. Approach, ppit 1, back up to approach, to ppit 2 approach, then down to ppit 2, then back up to ppit 2 approach, to ppit 3 approach, down to ppit 3, and then back up and then go to this start place where it's a safe location. So it's not a particularly challenging program. We're going to declare the variable, so JStar is what we call a joint RS position. A T-tool is a variable called a tool. ppit 1 is we're going to call it a variable called point RX, same as ppit 2 and 3. And similar, so we're going to have to define all those before we can run our program. And then we need to tell the robot where its new tool center point is. So imagine you've got this robot, and when you buy it off the shelf, it just doesn't come with this blue magnet gripper on. It just comes like where its wrist would be, if that makes sense. And it thinks its tool center point is where the wrist is, not where the end of this blue magnet disc is. So we need to add this offset to it. So we need to define that, and that's where we get here. If you were really accurate, it should read 25. Because I was doing it visually, it's just a little bit less. And then we're going to teach it where ppit 1 is. We're going to move to where we want it to pick something up, and it's these are the values for this example. And we're going to say that you are at ppit 1, ppit 2, and ppit 3. So we're declaring them. This is the emulator, and if you set up the emulator like I told you at the beginning to use the big emulator, this looks very much like the teach pendant that you would use if you had the robot in front of you and you picked up the teach pendant. So the graphics are very the same. Everything, when you get this window up, you can press the buttons using the mouse. Everything in this white window here requires you to press the return key, and the keyboard is quite clunky. Then there is a slightly newer version of this, which is almost like a Windows, like an iPad style. This is what you would end up if you'd forgotten to set the emulator running in the larger mode. It's a little bit clunky, I don't like it. So what you then do is you go and find the program we've written called loop, and you run it. You set a couple of things up, you run the program, you switch the simulator on by pressing this little button here, and hopefully your robot will move to 3 different positions, and afterwards you can record it as a movie clip and stuff. For this tutorial, we'll probably stop just here, because when you render things out and stuff, and you've got screen capture software, it doesn't work particularly well. So let's move over to the Stäubli software. Okay, I've started the Stäubli software. I've got quite a lot of files here already waiting for me of what I've been working on before. Yours will probably be empty, or you might have just one cell there. What you've got to realize with this software is it is extremely path dependent. So you can see here first the example. This is what we're going to do today, by the way, this Scara robot. And I've got a path and it's defined by where I put it on my laptop. You cannot go to that folder, copy it to a USB stick and go somewhere else and put it in a different folder file structure. It really needs that C_users Foley, etc., etc. The best way, if you want to do some work at university, then go home, etc., is to keep using the saved copy. It will sort out all the paths and stuff. Today we're not going to import any 3D models, but we do have some. We will have some models in there, and when you create the cell, it'll create several folders, and all of this information is in those folders. And again, everything is path dependent, which it makes it very, very, very hard work to move from one place to another. Let's go and have a look what we've done, what we're going to do today. So the tutorial asks you to go to settings and go to emulator. If this is in the computer labs, you'll probably find that it's the standalone. It might not say this, don't worry about it, but if it says start in standalone mode, make sure that's ticked, and that'll mean that the large emulator appears. I'll say OK, and this will bring you into the Stäubli environment. You need to go back one, so click on here. Select the new wizard, and let's save this somewhere that I've not saved before. And we'll call this underscore robot, and say next. Add the controller, and I want to go to a TS40, so it's the top right one, so make sure you select it and say OK. I want some input-output ports. I may decide to use them later on in another tutorial. This is the controller we've got at the university. Currently we've got a not a TS40, we've got a TX40, which is a slightly different model, but we'll stick with the same controller. And it's asking for some sort of confirmation. Are you happy with what you've chosen? Yes, we are. And quite confusingly, you end up in this view with no robot. I've no idea why it defaults to this sort of blank perspective view, but what you've got to do is select the show 3D view, and hopefully in a couple of seconds the robot is being copied into your scene. You can see what's happened as well. Down the left hand side we've got something called the tree. The tree is now starting to be populated, and there's our robot. I'm going to get rid of this error list and the one underneath. Come on. There we go. Just to make you aware of, I'm not using a mouse because I've got not enough USB sticks with the microphone and the software USB dongle, so it is quite hard to drive this software, but hopefully we'll get through it. So what we've got down the right hand side is we've got the Cell Explorer, the data, and the geometry. They look very similar, which they are, until we start putting things in. So the program tends to be developed in the Cell Explorer. Specific data about this cell appears in the data, and the geometry, the points and stuff like that. Okay, so let's expand our Scara robot cell. We've got a controller, and we've got a robot in there at this moment in time. If I right click on there and I do joint mode, you can see what happens is I've got joint 1. Just try and grab that. Yeah, there we go. So that's joint 1. That's joint 2. This will be the up down, and the other one will be the rotation and stuff like that. Yeah. Okay, so I've just clicked on that to re-zero it and stuff like that. I'm just going to close this and right click and do Cartesian. So it's more related to the end effector, if that makes sense. So the Z, just you can see it going up and rotating and stuff. I'm going to put it back to 0 just for me. I think it was 400 actually. There we go. Put these back. I'll leave this. I'll leave that. It doesn't really matter. Okay, so we've introduced the Cartesian and joints. If I'm honest, I don't use a joint rotation very much, if at all. Right, we're going to do some modeling now, so I need a little bit more room on the screen, so I'm going to get rid of this down the right hand side. I'm going to go to the modeling tab. This package is not a 3D modeling package at all by any stretch of the imagination. If you need to do some 3D modeling, do it in Autodesk Fusion 360 or SolidWorks or whatever. Think about what detail you need when you bring it in, because it is this software doesn't like really high polygon count and stuff. You want a representation of the shape in this software, but you don't need all that detail and stuff. So just be aware of that. It doesn't. You don't need every chamfer or radius or whatever. But in here we can do some boxes. We're going to do 2 boxes. We're going to create a box and use it as a bench, and then we're going to create a little booster box as such. So because that's nearly as far down as it can reach, and so we need to pop a little bench up there, and then we're going to put a little magnetic gripper on the end. So let's add a box, and we get this default box. Sometimes the properties window doesn't appears, but nothing's in it. It might be because you've sort of accidentally clicked somewhere else, and the object's not selected. So it's offering properties, but this blue box is not selected. So if you click on it, let's click on it again. If you get if it struggles selecting, you can always select it in this tree menu down the left hand side. So I've got a box. It wants to be 1,000 by 1,000 by 50. I've changed the color, but it's up to you. Just to show you can change the color. FF 9600. It won't change here because it's green, and the green basically means it's been selected. This green is defined. Remember when we changed the emulator to the large emulator in the settings? If you don't like it when you're selecting going green, you can change it in there. But actually, let's just have a look through. Okay, I just wanted to change the name of it as well. Box is not a great name, so let's call it bench. Okay, now what we need to do is we need to move it because it's just slightly too high. It was 50 millimeters thick, and it's the way it does 25 up and 25 down from the 0 where the bench is. So we need to just push it down by 25. So what we can do is select it, right click, and edit position. And we want to move it in absolute terms -25. So what should happen is the green, currently green box should drop down just a little bit, and it should just be touching the base of the robot, which is fine. Okay, done that. Let's go and create another box. Click on it to select it. See if I can get this window a little bit bigger. Okay, and I want it to be 400 by 600 by 250. I'm happy with the color, and it's going to, well, box 1 is fine for this object. Okay, and we can see actually on the right hand side that the edit position is defined as box 1, so we are going to move it to absolute position 300 X and 125 in Y, and that's fine. Okay, now we need to create a little cylinder that's going to go on the end of the gripper, and it's going to represent the magnetic gripper. So we can power it up, sort of on and off as such. You could go to a manufacturing company we bought from Shunt Grippers, and they will allow you to download 3D models of their grippers and stuff, which is fine. They tend to be quite high detail models and stuff, and they can slow your graphics card down, your graphics card down and stuff. So just have a think about that. But for us, we're just going to put a cylinder on the end. I'm going to close this edit position, give us a little bit more room, and I'm going to add a cylinder and properties as it come up now. Yes, we're in the cylinder, and I need, it's quite a small cylinder, so it's 25 thick by 50. I don't want a cone, I want it to be a cylinder, so 50-50. And I'm going to call it tool 1, because I'm going to change its name to a tool. Actually, I should have kept the window open earlier. It's not a bad idea to show you. If you come down to the left hand side of the tree and expand the geometries, you can see the object called tree. Right click and edit position there. And I want to change its absolute position to 800. If you just click on there, you can see it now. If we want to attach this to the end of the robot, but you can see it's 90 degrees out of sync, so we need to rotate it. So let's rotate it minus 90. But just before I press return, notice that the coordinate system of this cylinder is the same as the coordinate system of the 3D perspective view. When I rotate it, it's no longer the same, and we really do need it to be the same as this. So what I need to do now is right click again on my box and do edit reference frame. That's this coordinate system within there, and it's come up with this. So it's editing the reference frame, and I've rotated it 90 degrees. And let's just change it back, and that's okay now. That's okay. One thing with editing the reference frame, it's the same as clicking this icon along the top in the model, the fourth one along, edit reference frame, but it's a toggle. It's currently still on, so if I did any more work, I'd really mess this up, and you can accidentally move this reference frame all the way around the room, and you regret it later on. So do remember to switch it off. Okay, so now currently the robot, sorry, the Stäubli software just thinks this is a cylinder. It doesn't know it's going to be made into a gripper of any kind or a tool, and so we need to right click on it, and we need to make it into a new tool. And nothing too much happens. Maybe we've got a little bit of change in the description, but what's happened in the tree down the left hand side is we've got this new menu option, the tools. So let's see if we can. So we've got tools 1, which is what it's now called. Oh, come on, expand. Tools 1 and expand tools 1. And what we've got there is we've got a 3D model called Tools 1, and we've got something called a handle and handler. Really, really important, these sort of things. If we look at the robot, if I can try and expand that, handle and handlers are where things can grab hold of. So we've got this robot. It's got a controller. We know that. So this is the sort of the box underneath. It's got a base to the robot, and we've got a joint 1, and we're going to have to go all the way down these joints to get to the end. Joint 2, joint 3, and finally we're handle. If I click on this handle, basically it's like being at the end of this robot. It's not a great view to see it. What you might want to do actually is just turn your screen round slowly. I'm going to try and position this so it looks useful to me. I think my computer, which is quite a nice laptop, but it's still struggling. I suppose it is getting the screen capture software and this advanced robotics graphics package in there. I'm going to have to deal with that. I'm going to have to stick with that. So along the bottom is these faded out. Yeah, there we go. Little icons. I use the rotate. I'm going to change it back to the arrow key now. I'm going to expand the cameras. It's not the best view in the world, but without a mouse, it's quite hard. So I'm going to right click on there, and I'm going to insert a camera. I'm going to select it, and its name is here, and I'm going to call it Scara. I can't think of a better name for it at this moment in time. What that'll mean is if I move away and stuff, I can just double click on Scara, and it will bring me back to this Scara robot view, which is, like I say, it's not great, but I can work with it today. Anyway, going back, we've got this robot. It's got a handler at the end, and we've got the tool, which has got a handle as well, and we need to make sure that these are positioned correctly. So let's go to the top view. There's our magnetic gripper. You can click on it, right click, and we can do a close-up. So let's get a bit closer to it. A bit too close. Click on the zoom out. Let's just get a bit further out. Oof. Sometimes it's like driving an Arctic lorry with this. see if I can do it. This is where you really appreciate a mouse. Right. Right. So we've got a handler, handles attached to handlers. This shape is really, you know, there's not really an up or a down, if I'm honest, because it's a cylinder. But if we really important, we need to make sure we get the handle and handlers the right way around. So handle needs to be at the top, and that will connect to the robot handler. So let's edit, and we're going to, you can see that is the handle, and it needs to be at the top of the box. So let's see if I can get a better view. It's not great, is this? Struggling a little bit. Let's have a look, see where it is. So that needs to be at just at the top of the box. It is central, so I'm fortunate with that. Let's go to the handler. That is where it should be at the bottom, because that handler is where it can connect to certain things. So when we go and pick up our box, it will pick it up from the point of where the handler is. So that should be further down. So it should be just touching the bottom. So that's that. And remember to switch off the edit again, or else you're going to suffer the idea of you do some work and you realize you're moving the handle and handlers, and it can be a nightmare. Right, what I'm going to do, I'm just going to click on the base of the robot, because this cylinder is going to jump to the robot flange, and it's because it's touching the box at this moment in time. It's probably not the best place to be. But I'm just going to Cartesian. I'm just going to lift it up a bit. Let's go. There we go. And then let's click on the robot. Sorry, the gripper. Come on, go green. There we go. And right click and attach to the handler of the robot TS40. So if everything goes right, that new magnetic gripper should jump to the robot. Yep, there we go. There we go. And it just seems wrong. I wonder if I've got my handler and handles the wrong way around. So I think I might have, because it seems quite high. So I'm going to detach it. Let's move it to the side. Come on. There we go. Let's okay. I think I've got my handle and the handle is wrong way around. So let's do that again. Click on edit. Let's move that down. Come on. Just move it out of the way for the second. Get my handle. Push that up. Yeah, handle needs to be at the top to grab. So handle needs to be at the top. I thought I'd done this. Handle needs to be there because it connects to a handler. And there we go. And let's put that back on the base. And switch edit off. Right click and attach to the robot. Yes, that looks a bit better. You can see the flange of the robot, and then that. And what should happen now is if I start moving my robot up and down, my magnetic base goes with it. Right. At this moment in time, this robot has come into the room. Imagine buying it off the shelf, and it knows where the end of the robot is. This the end of this flange is, and it thinks that's where the tool center point is. But we've just put a 25mm flange on there. So the tool center point is actually 25mm offset, and depending on what type of grip you put in, that all of that matters, especially if you go into predefined locations and stuff like that. So we need to tell the robot what the tool center point is. Let's go to the handler of the tool, which is right at the base. Right click on it and set as tool center point. We're going to come back here in a second because we also need to get the actual values and stick that in, but we're going to do some copy and pasting beforehand, so it's no point in doing it now, so let's just do that. Right, so we've nearly defined everything. What we want to do now is, this is just defining the cell that we're doing. We've written no code and stuff, so if we right click on the controller in the Cell Explorer window and do a new application, and let's call this loop. If you want, it's probably good practice for you to go and have a look at where all of these files are being stored and stuff. Loop should be a subset of in your folders. You should find a small folder called loop. Now there we go. So that's our application. You can have multiple applications. You can, if you've done with that application, you can close it. Close it does not delete it. It just means that you're not seeing it. And because if you do lots and lots of tutorials on this robot, it can be quite confusing which ones you're working on. So you can just close it, and you can always go back and open one, reload them and stuff like that, or you can duplicate them. What's happening now, if you go to data and stuff, it's all coming through. So we've got loop, you've got certain things here that actually stands for motion descriptors. I don't know if you can remember, but in the program we had M fast and M slow. They'll be defined in that subfolder in a little while. Coming back, we've got our program area, which is a start and stop. We're not going to do any amazingly advanced programming, so what we tend to do is put all our code in the start area, but really what that will be is the beginning of a shift. Is this something that this robot needs to do only once at the beginning of the shift? You know, sort of warm up, check everything's there and stuff. And similarly, the stop is it's closing down. It needs to maybe you have a gripper change and you want to put all the grippers back and then switch off the machine. But for us, we're just going to put everything in start. So I'm going to double click on start. Sorry, expand it and double click on start. Waiting for the program window to come up. There we go. It's a bit slow. Let's get rid of this. So we've got a program beginning and end, which is not particularly brilliant. So what I want you to do is go to the tutorial booklet and copy all the code in, or the Word document, much easier, and just copy paste. That's what I'm going to do. Okay, what I've done is copied and pasted it. I do this quite a lot. I copy and paste and accidentally leave the beginning and end again. So I've just copied it wrong. Right, just delete that. So we've got this beginning, end, and we've got a for M4 loop. It does this 10 times because we've got a counter I, and we've talked through the code, but basically it goes to a position called start, goes to an approach point, PP1, then goes to PP1, then goes back up, so it's going up and down, and then eventually it goes back to the stop. So this code is okay, but if we go to the valve tab and we run it, we're going to get a load of errors. Okay, when eventually it comes, here we go. So we've got 13 errors, and what it's saying is I don't know what I is. What's JStart? These are not standard Stäubli names as such, so we need to define them. And the way you do that is you sort of highlight I, right click, add, new data, and you come up with this window. We're going to see this window quite a lot over the as we define all of these. I is a numerical value, it's a number. Let's just say okay. Interestingly, if you go here, you can see now I've got in data, I've got a numerical value. It's 1 at the moment, 1 numerical value. I know now I need to declare JStart. So right click, add new variable, and it's it's a joint RS, sorry. And click OK. T-tool, that we need to define in a little while, but I'll explain that. That's the dimensions of that cylinder we've just added to it. So that 25mm cylinder, so it's okay. And fast, that says how fast you want to move. So it's a motion descriptor. And we can put the values of what that is, so we don't have to write all this big code, this big value in every time. We just save it as a variable, and if we need to change it, we can just come to the motion descriptors, and it will update the whole program. So if we go to motion descriptor now, we've got this mfast in there. We've got a variable called tppick, right click, add, new data. What you should be working out is, because of these little letters in between the small t, small j, small p, it's recommending that we pick point RS. That's the way I've written the program. It's picking up on the first letter, small lowercase, and it's recommending, and all of that should be fine. So it's a point RS. This TRS, right? So let's add that. And this is it's a translation. It's when the robot comes and it's hovering over our little object we're going to pick up. You don't want it to go straight there. Imagine you're picking up a cup of coffee and you're a robot, and you go and grab the cup of coffee halfway through the height of the mug. What you would do, imagine you've got a claw-like hand, you would knock the mug over. What you need to do is go above the cup of coffee and then drop down on it and grab. So you need this sort of little distance further up. You could create it as another point, but what you do know is that point, that above your cup of coffee, needs to be always where the coffee is. So if you can just create a little offset value. So if I say OK there, and in here we've got it's now appeared in the data. If I go down, eventually I'll find it. There we are. If I double click on that, we got this window, and I want the robot to go -50 above the robot, above the object. So it'll go to pip 1, but just -50 higher up, hovering above it. And every time it comes up with an approach command and they pick up that value, you can have as many approach values as you want. And it's just if rather than writing -50 every time, I giving it a variable name, and if I change my mind and I want -75, I just have to change it in one position rather than all of these different positions. Right, I've already defined T-tool. I haven't defined mslow, so right click, add, new data, motion descriptor. I haven't told it what yes, I have told it what ppip1 is. I haven't told it what ppip2 is. Add new data. Yeah. I haven't told it what PPIC3 is. Add new data. I think I'm okay. We'll check. Go through check. Yep, got no errors, so I'm looking okay now. Go back to our 3D view. Right, what we now need to do is we've got a tool in the data window, and we need to put an exact value in from the distance from the end of the flange to the end of the actual magnetic gripper. So what we do know is that it's related to the tool handle. So if we right click on here and we do copy data, then we double click T tool and we click on this little window cell right at the beginning, right click and say paste. Strictly speaking, it should be 25 because it's 25 long. When I was moving the handle and handle up, I must have been slightly out, but it's absolutely fine for this example. Move to the end, and what O time and C time is how quickly does the gripper take to work. So if it was a traditional gripper with sort of fingers opening or closing, it has an amount of time to fully open or fully close. Or a magnetic gripper, it doesn't happen instantly. So you're just saying how many seconds does it take for the magnetic gripper to switch on and off or open and close. Okay, so we've defined everything now. Now what we need to do is tell it where the points are. So we've got point 1, point 2, point 3, and J start. So we go to the geometry tab, go to the loop, and we've got the 3 points here. The J start is further down. So if we go to PPIC1, right click, there we go. Right, if I now click on the base, you could just manually move this, but and the values I'm going to give you now are just for an example. It doesn't really matter where your PPIC 1, 2, and 3 are, but I'm going to give you some exact positions just to give you an idea. So I'm going to give it 250 in X, 120 in Y, and 15 there. So that is going to be where point 1 is. So we've moved it there. Now we need to tell the software that represents point 1. So if I right click on that point there and see here with configuration means I want the elbow to be bent that way. Yep, so imagine that's your left shoulder and your left arm coming round and your elbows pointing. Naturally, that's absolutely fine. This robot could actually bend the other way and be in exactly the same position, but I want the configuration of this robot to be like that. So I want here with configuration. Right, now, so if we go to point 2, and so we've taught it point 1, so point 2, let's have a look. It's a little bit weirder. You don't have to be exact with these numbers. It's just somewhere else in the room as such. 5997. So it's at the other end of the bench, and that represents point 2. So right click here with configuration. And let's expand point 3. 2, 3, minus 24.39. You'd have thought I'd have been a bit tidier. And it's somewhere in the middle. And that represents point 3. So if I right click on there and see it here with configuration, and Let's just move. Let's just move this up a little bit for Jace for the robot home position. Just scroll down. Okay, come down to the bottom here and find J start, and this is just a location that is a safe place. I'm just going to put it just above 0.3, so we'll just type in 80 there, so it's just above there, and I'm happy with that. So just here, you can check out things. So if you right click on pick 3 and do move to, move to, move to. Make sure you put it back at 3 for now. Right, so we've defined our tool center point, we've defined our tool, the robot and everything. What I want you to do now is we're going to run the emulator, so we can actually just reduce this properties window, don't really need it for now. Okay, we've got everything set now. Let's right click on the controller and show emulator. And basically what you've got here is the a view of what the pendant would look like in your hand. It's got the menu structure and some of the buttons that you see. Everything in this white window, to access it and stuff, you must use the computer keyboard. Down the right hand side, these buttons along the bottom do work with the mouse, but everything in this white window is keyboard oriented. So we want to run an application, so let's press return. It is a Val3 application, so press return. I've got a disk on this laptop and a USB. The USB is the Stäubli software dongle, so it's neither in there. So I put the right hand key. I've got one application at the moment. If you had multiple applications, you'd have them all listed in there. But I'm going to press return on that. I'm going to go to the Stäubli software, because if I run this now, it would run, but you wouldn't see it simulated. It's very frustrating. You'd think by running the application, you'd see it running in the background. This animation would run, but it doesn't. And as soon as I click away from this, what's going to happen is the Stäubli window disappears. I need to then click on the simulation button. It's started. Looks like the robot's gone to its home position as such, which is okay. You might, when you come to this on your emulator, it might default to being where the hand is, or sort of manual mode. Click this button until you get down to the second from the left. What that means is when you press move, you can let go. If you're on the first one, you have to hold down the left-hand mouse button up for the whole 10 loops of this. Let's put the power on. Yes, we want to run that. Okay. It's currently at 75. Let's drop it down. If you were trying this on the real robot, you'd be running at 5 or 10% speed. In the next tutorial, we're going to put a box on here where you're going to go and pick it up and move it around. The graphics engine that comes with Stäubli is not great, if I'm honest. And if you run this simulation really fast, it sometimes doesn't pick up the box, even though there's nothing wrong with the program, and it'd be fine if you sent this to the robot. If you actually want to see it physically pick up, sometimes you just have to drop the playback speed and stuff. So let's say move. Yeah, so it's picking up, it's going to the start position, it's going to approach 1, goes down, goes to approach 2, goes down and back up, and then goes to approach 3, then down and back up, and then that's the one around the loop, and it keeps going. Very quickly you get a little bit more and you just want to speed it up, so let's crank it right up. So it's going. When it says 100%, by the way, that's 100% of an average payload at the end of that robot arm. So if you're picking up really light things, weirdly enough, you can actually go faster than 100%. What the tutorial asks you to do, by the way, we'll switch this off now. You have to switch this off and then remember to switch the simulation off, and then you switch that off. If not, what happens is you get a little error message and you have to just click on it, and it's absolutely fine. The tutorial asks you to record this, and you can record it using, probably the best one is the Microsoft Video 1. Save it somewhere good. And then you run the emulator and it just records everything that's on the screen. It tends to be very, very large file sizes, if I'm honest, but you should be okay. Keep with the defaults and you should be okay. If you mess around with these or pick some of the other ones, it renders out in black and white, or you get really horrible stripes and stuff. But I'm not going to cover that in this tutorial because I'm already capturing the screen, and the screen capture software I don't think would work particularly well. Okay, so that's a tutorial on setting up a cell for the Scara robot. We've introduced importing a robot, TS40. We've looked at modeling boxes and cylinders. Like I say, that's about as much as this software can do. If you wanted to bring in a 3D model, that's fine, but don't overdo the 3D modeling of it. It's a representation. We've then looked at creating an application, and you've looked at some code. It's not really challenging code. It's just basically going to 3 different points and approach points and doing it 10 times. We've also looked at declaring the variables and teaching point positions and stuff. And then once we were happy with this code, we would go to the transfer manager and we would transfer this Val3 code to the actual robot. Depending on how confident you were that you picked P.1, 2, and 3, etc., exactly the same as a real-world environment, you could just run it. I wouldn't recommend doing that. I would send it to the robot and then reteach the real-world positions of P.1, 2, 3, and J start, and then run the program. What you can do then is, with these real world coordinates, you can use a transfer manager and get them back off the robot, and then you'd have the real world data matched, and you can actually sync up the Stäubli software with the real robot, and as such, when the robot moves, you'd see the simulation move at the same time, and it'd be driven by the robot, which sometimes can help you. Anyway, you've learned an extreme amount there. Hopefully it's been useful. Thanks for listening.